Hello dear students, I am Samir Velankar. I welcome all of you to this first video on the topic N-Queen problem. We are learning set of algorithms which are called backtracking algorithms. Now the best way to understand what do you mean by backtracking is by seeing a problem called N-Queen problem. Now in this problem we are given a chessboard. We are given a chessboard which has n rows and n columns. Now I know that chessboard is always 8 rows and 8 columns. But we have generalized the problem. Instead of saying that we have a chessboard of 8 by 8, which is usually so, we will say we have n rows and n columns in the chessboard. So we can have a chessboard of size 4 by 4. As shown in the picture, there are 4 rows and there are 4 columns. So we have got a small chessboard and we are given n queens. So for a 4 by 4 chessboard, 4 queens are given. Now we want to place all these n queens, that is 4 queens, on the chessboard in non-attacking positions. Now watch, the problem is really very challenging. Now if we have a 4 by 4 chessboard, here we go, 4 rows and 4 columns. Now one of the solutions of this 4 queen problem is that you can place the first queen at the position which I am showing, first row and second column, and the second queen can be placed in second row and the fourth column here, and the third queen can be placed in the third row and first column, and finally the fourth queen can be placed in fourth row and third column. Just check. Now I assume that you know the game of chess. You know that queen is the most powerful entity in the chess because queen can attack horizontally or vertically or diagonally. Now you just watch the first queen where we have placed. Now this queen will not attack anyone horizontally, obviously, because there is no queen here in the same row as this queen is being placed. It cannot attack any queen vertically also because there is nothing placed in that column. And the first queen, which I am again pointing to, cannot be attacking any queen diagonally. You watch the diagonal here, which I am drawing. There is nothing placed in the diagonal. So the queen 1 is safe and no other queen attacks this queen. Similarly, second, third and fourth queens cannot attack any other queen. Neither they will be attacked by any other queen. So we say this is one of the solutions for 4 queen problem. The point is that this is not the only solution. Now the other solution to 4 queen problem can be something like this. Again we have 4 rows and 4 columns. Okay. And the first queen will be placed in the first row but the third column. Here we go. In the earlier solution, first queen was placed in the second column. Here first queen is placed in the third column. Then the second queen can be placed in the first column. You can clearly see this second queen will not attack any queen diagonally, isn't it, up till now? And horizontally is impossible because we are not going to place any queen in the same row and in the same column. So vertical attack is also not going to be possible. Now the third queen will be placed at such a position so that no other queen attacks. That will be the fourth place. You just check it. And the fourth queen will be placed in the second column. So this is another solution of 4 queen problem. Just imagine a 3 queen problem. Now it is very easy to see that there is no solution for 3 queen problem. If we say we have got n by n chessboard and here n is 3. So 3 queens are to be placed on a 3 by 3 chessboard. Then there is no solution possible. Even if you place the first queen in the corner here, the second queen, the second queen can't be placed here. It will attack vertically. Second queen can't be placed in the second column. It will attack this queen diagonally. Third queen can be placed, agreed. Okay. Sorry, the second queen can be placed at the third column because it is not going to attack any other queen now. But there will be a problem of the third queen. Now watch, the third queen cannot be placed after placing the first two queens. Because if you place the third queen here where I am pointing to, it will attack this first queen vertically. So you can't place the third queen in the first column. You can't place the third queen in the second column either because it is going to attack this previous queen diagonally. So you can't place it here either. And obviously at this position where I am showing, it will attack the previous queen vertically. You can just check for any solution. Three queen problem is unsolvable. There is no solution existing. But for four queen problem, there are two solutions. Similarly, for 8 queen problem, if you have 8 by 8 chessboard, I can't dare to solve it. 8 queen problem, it will be too big to draw 8 by 8 chessboard. But for 8 queen problem, there are 72 solutions. You can place 8 queens on the chessboard in 72 various ways so that they don't attack each other. Now, as this number of queens increase, let's say that we are solving 16 queen problem. That is, we are given 16 by 16 chessboard and we want to place 16 queens in non-attacking positions. Obviously, the number of solutions will increase and complexity of the problem will increase. So that is what the problem is. Read out the problem statement again. We have been given n by n chessboard, n cross n chessboard and n queens. And we want to place all these n queens on the chessboard in non-attacking positions. Now, the best way to solve this problem at the moment is by using backtracking method. Trust me, you will understand backtracking, meaning of backtracking after learning all these diagrams. Let's see. Let's start with our chessboard here, 4 by 4 chessboard we are solving. Let me increase the font. Okay, I think this is readable. Fine. Let's start with our chessboard here and we will place the first queen obviously in the corner of the chessboard, that is row 1, column 1. So we have said that we have placed queen 1 successfully in row 1, column 1. So we must proceed to second queen. Now one thing we can guarantee here is that second queen while placing, there is no point in placing second queen anywhere in the same row where we have already placed the first queen. By that way, we can avoid at least the horizontal attack. I hope you are understanding. So every queen will be placed in a separate row. Rather, second queen will be placed obviously in the second row. Third queen will be placed in the third row and fourth queen will be placed in the fourth row. So where can be the second queen placed? Now let's try to place the second queen here. No, 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 this is not the place. It will attack the previous queen vertically, isn't it? So let's go further and try to place the second queen in the second column of the second row. This is also not possible because it is going to attack the previous queen diagonally. You know the queen can attack diagonally. So even this is not possible. Let's go further and try to place the second queen in the third column, and this is much better because this queen doesn't attack any queen previously placed vertically, and horizontal attack is impossible because we are not going to place any other queen in the same row. And obviously the diagonal attack, you can see it is not attacking any queen diagonally either. So after placing the first queen, we are successful in placing the second queen. You observe, second queen has been placed in row 2, column 3. So far so good. Now what? Now let's try to place the third queen. We are going to fall in trouble now. Now we have placed the first queen in the row 1, column 1. We have placed our second queen in row 2, column 3. Okay. So they are not attacking each other right now. First two queens are really in peaceful arrangement. Now let's try to place the third queen. Well, we cannot place third queen here. No, it will attack this queen, first queen vertically. So that's not possible. Let's forget this position. We cannot place this third queen at this place, second column either, because this is going to attack the previously placed queen, second queen diagonally. So we just can't place the queen in the second column either. Third column is impossible. It's going to attack the previous queen as seen. You can't place it here. So we will try the fourth column for this queen. This is also not arrangement is correct because it will attack the previous queen diagonally. So we will try to jump out. I mean, this queen, you watch. Third queen has tried all the columns and none of the columns were suitable because placing this queen anywhere in any of the columns was disturbing the previous queens, isn't it? Was attacking the previous queens. So in the event of placing the third queen in these columns, the queen has gone out. So we have said queen 3 cannot be placed in row 3 anywhere in row 3. You will wonder that if we cannot place third queen in row 3, then why don't we place it in row 4? Agreed, you can place it in row 4 here. But then hello, where will you place the fourth queen? You will again have problem for fourth queen. Try to understand, important thing is that third queen has moved out of the chessboard because none of the columns were ideal for this queen 3 because it was attacking all the previous queens that you have placed. So what do you do then? You backtrack. That's the word, backtrack. You do backtracking and you don't just go back to first queen, but you go to the latest queen that you have placed. So you were placing third queen, correct? You were unsuccessful in placing third queen. So you backtrack to the second queen. Here we are back to the second queen and you try to move this queen to the next position in its same row. So you'll say that how about not placing this queen, second queen over here and placing the queen in the next column? Wow, even if you place this queen here, it's not going to disturb the previous queens because the previous queen is not diagonally there, which it will attack. So you can place this second queen at the fourth column. So what is backtracking really? Backtracking means if you are stuck while finding the solution, then you can go back to the earlier solution, partial solution that you have found. This is partial solution, isn't it? And you could not place the third queen, then you go back and you rectify your partial solution, claiming that partial solution must be wrong. So I will try to readjust the partial solution and then come back again to the third queen and try placing it. So we have done backtracking. We have backtracked to the second queen. And now you watch, second queen was actually placed over here in the earlier solution. It has been moved to the next column, which is also correct. It is not attacking any previous queen. So queen 2 is repositioned to column 4. Okay. Now let's go and try to place the third queen again. Recall we were stuck. We were not able to place the queen 3. Now the first queen is placed in first row, first column. The second queen is placed in second row, fourth column. Now try to place this third queen. Remember, third queen was out. Let's try to place it again in the third row and it will find the ideal place over here, you watch. Because it is not attacking any previous queen vertically. Diagonal attack is out of question. We are not going to place any queen in the same row. And diagonal attack, sorry, horizontal attack is not possible. I am so sorry. In the same row, there is no queen. Diagonal attack is also not possible. There is nothing in this diagonal, you watch. Hence, we have successfully placed queen 3 now in row 3, column 2. Good. So we have now successfully placed 3 queens. Now let's try to place the fourth queen. Oops. Now fourth queen is going to trouble us again. You watch. We have placed first queen, second queen and third queen in non-attacking positions. Now try to place the fourth queen. Fourth queen cannot be placed here, vertical attack. Fourth queen cannot be placed here, vertical attack. Fourth queen cannot be placed here, diagonal attack, you watch. And fourth queen cannot be placed here, vertical attack. Oops, fourth queen has again moved out. It was not able to find out suitable place in row 4. So whenever we don't find the further solution, we will backtrack and rectify our earlier solution. So the point is, because we are not able to place the fourth queen, we will backtrack, but we will not backtrack directly to first queen. We will backtrack to the previous queen that we have placed, that is third queen, and third queen will be asked, hello, can you move further somewhere in your same row so that we can place the fourth queen? Now, third queen, if you move it further here by just rectifying its solution, it is not possible because it is going to attack the previous queen diagonally, and even this place which I am showing is not possible. It is going to attack the previous queen vertically. So this queen also moves out. What's going on, isn't it? You can check that even the third queen has moved out. We backtrack to the third queen and we tried to adjust its position to find out some new position so that we can place the fourth queen properly, but the third queen has also moved out. So what do? You backtrack again. You backtrack to the second queen, and wherever the second queen is, you try to place it further in the same row, but there is no other place and the second queen also moves out. Second queen indirectly is saying, hello, I have tested all these places. That's why I reached this column. And now you are pushing me out. Now you will backtrack, isn't it? Back to the first queen. That's what has been shown in the next slide over here. The second queen also has moved out and we are back to the first. So the argument I am making is there is no solution. There is no solution to four queen problem. If 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 queen 1, first queen, is placed in row 1, column 1, check this out. There is no solution. That means you should backtrack to queen 1 and you should move it further in its row and say, queen 1, how about placing you in row 1, column 2? Now let's see, are we going to get the solution? So now queen 1, check. Queen 1 has been placed in row 1, column 2 here. So let's try to now place queen 2 again. And queen 2, with queen 1 placed in 1, 2, queen 2 can be obviously not placed here. Diagonal attack, not placed here. Vertical attack, not placed here. Diagonal attack, but you can place the second queen over here. No trouble, isn't it? Let's try to now place the third queen. And you can find out that with the first two queens placed at their places shown, first two queens, well, you can place the third queen straight away at the position which I am showing 3, 1, because there is no vertically placed queen, there is no diagonally placed queen, and obviously horizontal attack is out of question. We are not going to place any queen in this row. So even the third queen has been placed, and now let's try to place the fourth queen. With the positions of the first three queens shown as I am marking over here in non-attacking positions, now the fourth queen cannot be placed in 4-1 because it's going to attack the earlier queen vertically. It can't be placed in 4-2 because it's going to attack the queen diagonally, previous queen diagonally. But hello, the fourth queen can be placed in column 3. There is no vertical attack and there is no diagonal attack either. Just check this diagonal. There is no diagonal attack. Hence, even the fourth queen has been placed successfully. So we have placed all four queens, check their places. They are in non-attacking positions. So how are we going to print the solution? Check that we are not going to print any chessboard on the screen while writing a program, but we are going to print the solution just in one line. Great. This is the solution 2413. That's it. That means how you read the solution is first queen is placed in second column. Yeah, really true. First queen is placed in the second column. Second queen is placed in the fourth column. Third queen is placed in the first column and fourth queen is placed in the third column. And what about the row numbers of the queen? Come on, first queen is placed in first row, second queen is placed in second row, and so on. So these are the column numbers of the queens that we are printing, and row number of the queen is understood. Ith queen is placed in the ith row. So that's the meaning of this solution that I have written. Observe the other solution to the four queen problem that I was saying was 3 1 3142. Observe. Do you understand this line now? This is the solution of four queen problem. If you actually draw the chessboard 4 by 4, if you draw this chessboard, and you understand the solution like this. First queen is placed in the third column. So first queen is placed in first row, obviously, but in third column. And the second queen is placed in the first column. Second queen is placed obviously in second row, but in the first column. Then third queen is placed in the fourth column. So third queen is placed in third row, but the fourth column. And the fourth queen is placed in the second column. Fourth queen is placed in the second column. You watch this. This is also non-attacking places for the queens. And there are only two solutions for four queen problem. Now, what is so interesting over here, many students, while teaching this in the classroom, argue that, sir, aren't you making this complicated? I mean, if we were given a 4 by 4 chessboard, we will randomly place the queens and we will get the solution. Of course, I agree, you can randomly place the queens. But look, this is an organized way of solving the problem, isn't it? Now, in this fashion, if you place the queens sequentially, the method in which it has been shown, not even a single combination of the queens is missed out, isn't it? We are not missing any single combination of the queens. We are considering all the combinations. Just imagine 16 by 16 chessboard given. Now you can't dream of randomly placing the queens, because the point is that we want to get all the solutions, all the arrangements that are possible. And all the arrangements can be only found out by using some strategic approach. And backtracking is one of that approaches. Now, when we return in the next video, I will tell you the methodology, the programming method that is backtracking or the algorithm to solve this problem. Thank you very much.